Gentlemen, this is Miss Humbert here. Today we're going to be doing Unit 6 Notes 1, Part 2. So we're going to be going over the second part of that note video. So we're looking at this first problem. It says movie ticket sales decrease each weekend after an opening. So it gives us a function that models the earning of a popular movie. In the equation, E represents the earnings in millions of dollars, and W represents opening weekend. So when W is 0. So we want to graph the function and estimate how much money that they made. So first of all, what I'm going to do is I am going to have X start at 0. So we're going to go 0, 1, 2, 3, 4, and then all the way up to 5. So now I need to plug in each of those values. So because we have a rate that was between 0 and 1, being raised to the exponent, our graph should be going down. So what we're going to be doing is we're going to be taking 49.9 times 0.692 and raising it to the 0 power. Again, you can be plugging this right into your calculator. If you need me to show you how, just let me know. So then I'm going to do 49.9 when I plug that into my calculator. And I do suggest you plug that in along with me, so you make sure that you're doing it right. So we're going to take that and we're going to raise it to the first power. So when you plug that into your calculator, you get 34.5. And then we're going to continue. Next, we'll do 2. And so we'll raise it to the second power. And when we do that, we end up getting 23.89. Raise it to the third. And when you plug that in your calculator, you get 16.54. What I'd like you to do right now is pause the video, do the rest of the calculations on your own, and then check it with mine. So go ahead and pause that video. So if you did it correctly, you should have done 11.44 and 7.92. So let's go ahead and graph that. In order to get to 49, or basically 50, by the top of the graph, I'm going to go by 3, basically million, because remember 49.9 represents million. So I'm going to go 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48. Okay, so 49.9 is going to be just above 48, which is going to be that point there. So if this is 48, 45, 42, 39, 36, 34.5 is going to be about right here. And then we're going to go down and we're going to have 33, 30, 27, 24, so 23 is going to be about right here. And continuing to go back down now. Again, we're going by 3s. So this is going to be 21, 18. So 16.54 is probably going to be about halfway. So this is going to be 15, and then 12, and then 11.44 is going to be just below the 12. So this right here, going on down, is going to be our graph, and we're just going to estimate the ends of it. Again, not crossing that x-axis. So this graph represents the number of movie sales for any given week. So going across here, my x's represent the week. Now let's take a look at number 8. It says that some people say the value of a new car decreases as soon as it's driven off the lot. So the function 25,000 times 0.82 models the depreciation. Depreciation, that word means going down. It's losing value of a new car that originally cost 25,000. V represents the value of a car, and T represents the time in years from the time of purchase. Okay, so again, we're going to go 0 years, 1 year, 2 year, 3 year, 4 year, 5 year. So when we get this 5-year answer, we'll get the answer for the car value after 5 years. But we also need to graph the function as well. So again, I'm going to do the same thing that I was doing in my calculator before. I'll do 25,000 times 0.82, and I'm going to raise that to the 0 power. Well, when I do that, I get 25,000. Now it's not being raised to the 0 power, it's being raised to the 1 power. And that's going to be 25,000 times 0.82 is going to be 20,500. Now I'm going to raise it to the 2 power. And when I raise it to the 2 power, 25,000 times 0.82 squared, I'm going to get 16,810. Then I'm going to take it and I'm going to do 25,000 times 0.82 to the 3rd power. and I'm going to get 13,784.2. Raise it to the fourth power, and I get 11,303. And then I'm going to raise it to the fifth power, so I get 9,268.4. So the answer to the car's value after 5 years, 9,268.4. So it's already half, more than half, or less than half of what it was originally worth, only after 5 years. Think about how fast that's going down. So in order for me to get to 25,000, what I'm going to do is I'm going to have each of these represent 2,000. Now, it's always good practice to do your scale, okay, and write your scale on the graph. So if we're going up by 2,000, I need to go up to 24,000 and to find 25,000. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So 25,000 is going to be halfway between 24. So here's 22, 20 is here, and then we're going to be just above 20,000. So this is 18,000, 16,000. So this is going to be a little bit more above 16,000 right here. And then that's 16,000, 14,000, 13,000 is going to be right about here, I would say. And then we're going to go, so that's 12,000, 11,000 is going to be about right here. So this is a depreciating value of the car. And eventually it is going to be worth next to nothing down the road. So let's go ahead and let's take a look at 9 and 10. So we want to see if the chart below shows exponential behavior. So what we do to do that is I'm going to see if I divide 25 divided by 10, 62.5 divided by 25, and that divided by that. I want to have a consistent rate of change. I want the number that they're being multiplied by to be consistent. So 25 divided by 10 is going to give me 2.5. 62.5 divided by 25 is going to give me 2.5. 156.25 is going to give me, divided by 62.5, again, 2.5. So since all of those are the same number, it does show us exponential behavior. So I'm going to go ahead and graph this. I'm going to have my y's go by tens, and my x's are going to go by tens as well. So I'm going over 0 and up 10 for the first one. I'm going over 10 and up 25, which is going to be halfway between 20 and 30. Over 20, up 62.5. So here's 30, 40, 60, and then 62.5. And we won't be able to fit 156 on there, so I want to make sure I'm off the graph before I cross that 3 line. So that's the graph that models that chart in number 9. Now, taking a look at number 10. What I want to do is divide 0.5 divided by 1, and that's going to give me 0.5. 0.25 divided by 0.5 is going to give me 0.5. 0.125 divided by 0.25 is going to be 0.5. Okay, so then what I want to do here is, like, since all of my rates are the same, I know that this does show exponential behavior. Since 0.5 is between 0 and 1, it does decrease. So what I want to do is graph this. So what I did is I went up 4. So 1, 2, 3, 4. This guy right here is going to represent my 1. So each square represents 0.25. So now I have 0, 1, 2, and 3. So I'm going over 0, up 1, which is right here. Over 1, up 0.5, this is 0.25, and then 0.5 right there. Here's 0.25, and 0.125 is here. So this is going to be slowly decreasing, and that right there represents my graph for number 10. So that concludes your note video for today. Thank you for listening.